Mike Landry here. This is the second in a two-part video on ANOVAs. In the first video, you'll remember uh, we ran an ANOVA comparing three groups of diabetics, 0 being those without a history of diabetes, the 1 representing those with type 1 diabetes, and the 2 representing those with type 2 diabetes. And we looked at the BMIs to see if there was any significant difference among these three groups. And you'll also recall we had this output, and in reading this output we went over the descriptives, and from this we can see, and again, if I was going to put this table in an APA paper, I would change the 0 coding here to being those with no history of diabetes, 1 being type 1, etc. But on this table we can see the mean for each of these groups in terms of their BMI, standard deviations, standard errors, the confidence intervals, and the ranges. We also noticed in the ANOVA table that the important numbers to report here, of course, is our F of 0.295 with degrees freedom of 2, resulting in a significance level or a p-value of 0.748, which we know is above 0.05, meaning these results show there's no significant difference in the BMI, the mean BMI for these groups. And I left off a couple of tables to come back to explore this in a little bit better detail. The first being the test of homogeneity, and the second being the post hoc tests. And if you recall, we ran all 5 post hoc tests, and I described the process where statisticians have their preferences, and in certain situations they prefer one test over the other. But we're going to just cover that real briefly to show you what that information means. This Levine statistic for test of homogeneity of variances is rather interesting because students get confused oftentimes with the significance level. I want you to think of it this way, that we really don't want a difference in homogeneity of variances. We want the variances to be rather consistent between our groups that we're testing. And so what we actually want here is the opposite of what we've been saying. We want a significance of greater than 0.05. So if you want to look at this as a good or bad thing, a significance of 0.699 means we would accept the null, that there is no variance in homogeneity. And so that's what we really want if you want to consider that. So this is an example of where the significance that we're looking for is actually greater than 0.05. So we could report that the Levine statistic significance of 0.699 indicates that the variances are fairly consistent, and that's you can think of that as a good thing. So when we ran the ANOVA, we noticed in this example that we had a significance of 0.748, meaning the difference between the groups was insignificant. But imagine if we did have a value that was below 0.05, indicating that there is a significant difference in these three groups. The question you might then ask is, well, where is that difference? Remember, we had three groups. If we're saying that there's a significant difference between the groups, is it between group 1, those without diabetes, and group 0, those without diabetes, and group 1, those with type 1? Or is it between those with type 1 and type 2? Or is it a difference between those with type 2 or no history of diabetes? And so this is where the post hoc tests come in. So you can look that I have all of the ones that we commonly see used. And just going through the tookies here, what I'd like to show you is how to read this. So remember, in our case, for our independent variable diabetes, 0 meant no history, 1 meant type 1, and 2 meant type 2. So here what we see in this first row is a comparison of those with no history with those with type 1 diabetes, and we notice the significance is 0.987, meaning there's no significant difference in these two groups. Secondly, we have the comparison of those with no diabetes, what we coded as 0, and those with type 2 that we coded with 2 of having a significance of 0.757, also a non-significant difference. And so then you'll see that the data is repeated. Instead of comparing 0 to 1, we now compare 1 to 0. And as expected, we get the same 0.987 that we've already seen. But we also have the comparison now of type 1 diabetics with type 2 diabetics, which gives us a significance of 0.829, indicating that this relationship was not significantly different. And then we again have a repeat, as we saw in the Pearson's correlation table. Now, instead of comparing 0 to 2, we're comparing 2 to 0 and 2 to 1, which we've already done. And that's why you see the duplication of these numbers that we have already mentioned above. So when you think about it this way, we had 3 groups. There's actually 3 different possible combinations. We can compare 0 to 1, 0 to 2, and 1 to 2, and we can determine if there is any significant difference between these 2 groups. If you want to think about this as being sort of like a t-test where we're only comparing 2 conditions in the independent variable, you can think that way if that is helpful. So anyway, we can see that the bottom line here is with the Tookies, we found no significant difference between any of the 2 groups in our independent variable. The other types of post hoc tests that are listed here also show similar results. You notice the Bonferroni is a little bit higher, maybe not quite as sensitive as the others are in this particular case. So I hope that explains how to read the post hoc tests, and these are numbers you could report. And again, I would typically expect to only see one of these run, depending on the statisticians or your preference given the situation. That's the most important data and the output of the Way ANOVA, and I hope you found this helpful. Thank you.